Okay, everybody, so this is going to be the video for Lab 4. I am going to walk through it as slowly, I guess, as I can, but you can definitely pause whenever you need to, take a little break, but just make sure that if you're walking away from things that you save them, and that you can definitely get back to them, because working inside of that VMware Horizon client thing to get into a UNCP desktop is not always the easiest. I hope that you are settled in and maybe you have, like, I don't know, your beverage of choice or whatever, because this one is a little bit of a doozy. So let me just first start with, what files do you need to accomplish Lab 4? Okay, so as you can see my screen, I have my paper pulled up. Your paper already has a ton of stuff in it, you guys. Like, you have already done your participant section, you've already done your whole measures section. You could technically go back in and add in your alphas in here throughout your measures section from Lab 3. And today we're going to actually do the independent samples t-test. And also, if you go down here, we're going to do the table and we are going to do the figure. So it'll take a hot minute, but it'll be good and you'll feel super accomplished by the time it's over, especially in terms of getting your paper done. I also have pulled up the handout that's all about how to conduct an independent samples t-test. We'll be using this. This is like our guide to doing the actual analysis in SPSS. So you will definitely want that. I explain things in sometimes excruciating detail in this handout. So, you know, you have options, okay? Let's see here. What else do I have? Oh, I have the data. You need the data. Most importantly, you guys, you need the data that is now your data. You see all these variables here, BF6R, BF21R, all those. You created all of those in Lab 3. Look, I have my mean version of extroversion, agreeableness, conscientiousness, all those, life satisfaction, you know, whatnot. You need this, okay? So you can't just go to the original data set on Canvas anymore, because you've done things, okay? I'll probably make another video for people who are like, oh my gosh, I've lost everything and I need to figure out how to get it back. Okay, I'll make another video for you. Okay, but right now you're starting Lab 4. You need your data set that has all the stuff in it. Okay, so the final thing that you're going to need for this lab is a syntax file that is available on Canvas. It's called syntax creating t-test groups or something like that. And when you open it, it looks something like this, okay? So it's just a syntax file, and I'm gonna explain to you why we're gonna need it. So let me just back up a minute. Independent samples t-tests involve comparing two groups on some variable of interest. Okay, so like when we did t-test in class, we might have been like, okay, I'm interested in comparing men and women on their love of dogs. Okay, so do men love dogs more, or do women love dogs more? Or I'm interested in people who are getting the drug treatment versus people in the placebo condition, and looking at their level of depression after they've been on this medication for like a month. Okay, so you have two groups. You'd have the drug group and the placebo group, and you're comparing them on their depression levels. Okay, so those are t-test sort of designs, and that's what we're going to need to have here. So your first goal of Lab 4 is going to be to come up with a hypothesis, okay, that involves comparing two groups on a variable of interest. And there are rules here, okay? There are rules. In fact, if you go to your handout here, it very explicitly goes through which variables you can use, okay? Because it's not just free for all on all the SPSS variables. In order to run the t-test, you have to have a variable that has two groups. Seems obvious, right? Because we were talking just like men and women, or we did drug and placebo. So you need to have that kind of a variable. And then you also need to have a continuous outcome variable. So that's like love of dogs, or depression level, or whatever, like I was talking about in those examples. For here, my example in this handout is, for example, I could predict that people who are older will be more satisfied with their lives than people who are younger. Okay. Now, in order to do that, I would have to have an age variable that just had two groups. Okay, a young group and an old group. And I would need some measure of life satisfaction. Okay, and I would be predicting here that my older group would have a higher mean on life satisfaction than my younger group. So this is the example I'll probably use throughout this lab video. So that means you cannot use this one. Okay, you have to pick something different. Okay, so for this class, you are limited in your variable choices because I made the questionnaire. So that's really all you have to work with. So this is probably not your ideal questionnaire. If you wanted to go out and design your own study, you'd probably be asking different questions, doing different things. But we've got to work with what we have. And in fact, I have a problem here because the only variable in our data set that has two groups is gender. And I really don't want to read a bunch of papers about gender differences. So what I've done is I've gone through and created the possibility that we could have some other variables that also have two groups. So I'm going to be helping you make these other three variables here. So I made an age variable that has two categories. And basically what I did was I looked at everybody in the data set and tried to divide it up so that I'd be roughly as close to 50% and 50% as I could. But it's really hard because you guys are relatively young, and so there's like a ton of 20-year-olds and a ton of 21-year-olds, and so you're not going to have even groups. But what this syntax is going to do is it's going to basically divide it so that you have one group that's 20 years old and younger. So essentially just 18 to 20, okay? And then your other group is going to be 20.1 and older. So if you took the survey and you're 21, you're old now. I'm real sorry, okay? But you're old, okay? So that's just how I had to do it. So I've got my young people and my old people. Let me just point out that keep that in mind when you're coming up with hypotheses. If you decide to use the age variable, like old is not really old. All right, so keep that in mind. I'm also going to be helping you create a GPA variable that has two categories. So you can see that here. The low GPA group is anyone with a 3.0 or lower. And then the high GPA group is anyone with a 3.01 or higher. Remember, I'm just trying to divide it at like this 50% line. Exercise. I changed that into a two group variable as well. So you're going to make one where the less exercise group is anyone who exercises once a week or less. And then the more exercise group is anyone who exercises multiple times a day, or not multiple times a day, multiple times a week or every day. Okay. So let me just go back over here to this syntax file because hopefully it makes a little bit more sense. So as you can see here, that is what this syntax file is going to do. Like, it's making a new variable for GPA that has two groups. It's going to make a new variable for age that has two groups, and it's going to make a new variable for exercise that has two groups. So what you're going to do is you're going to make sure you have your data pulled up, and remember this is your data that has all the stuff in it. Then you're going to pull up this syntax creating t-test groups file off of Canvas, and you are just going to highlight it and push play. Okay, so you don't really see much here in the output, but if you go to your data set, I don't know if you can see this, but you should have three new variables here. Make sure that one, yeah, okay. With GPA two groups, age two groups, and exercise two groups, and those should be all ones and twos. All right. So those are now some options for our hypotheses. Okay. All right. So let's go back to our handout. Remember, this is like piece by piece. I try to be really detailed here. So just make sure you're following along with it and you'll be okay. Okay. So you're going to have to choose one of the variables that has two groups for your hypothesis. Okay. So that basically leaves you with a choice between gender, age with two groups, GPA with two groups, or exercise with two groups. So you're basically going to be doing a study where you're comparing men and women, or you're comparing young and old people, or you're comparing low GPA and high GPA people, or you're comparing the low exercise, high exercise people. Okay, your choice. But you got to pick one. Okay, so you pick one of those. After that, or maybe in conjunction with that, I don't know, then you are going to have to choose your dependent variables. So let's say, like, if you pick gender, you're like, I'm going to compare men and women. Okay, that's great. On what? Okay, so that's sort of the next variable we're trying to find. Or you're saying, I'm going to compare low GPA people and high GPA people. Great. On what? All right. So this is where, again, you're limited a little bit because you're picking a continuous variable, which does apply to most of the variables in our data set. But I do not want you to use any of the individual items for the scales. So I'm just going to explain that in a minute. You can use any of the public image questions. Those are from friendly 1 to immoral 1. You can use any of the self-evaluation questions. Those are from purse rating 1 to purse rating 6. Or you can use any of the mean variables that you created in Lab 3. Okay, so let's go look at the data set and sort of talk through this. I'm going to switch over to variable view because I think that might be a little bit easier to see our options. I'm also going to hover between label and values and expand this. That way I can really see the questions. Okay, so let's say that you're like, all right, I'm going to do low GPA and high GPA. Well, then your next task is to figure out, okay, what's something that low GPA and high GPA people might differ on that we have measured here in the data set. Okay, so would high GPA people and low GPA people be different on how friendly they want other people to see them, or how confident they want other people to see them, or would they rate their physical appearance differently, or would they rate their work ethic differently, or their athletic ability? You see what I mean? Okay, so you can use any of these for your continuous variable. You could use anything from friendly 1 to purse rating 6. So any of those right here. Those are open games. So you could be like, oh, you know, maybe I want to look at young and old people. Okay, well, do I think young and old people would differ on, I don't know, their musical ability? Okay, but come up with something that makes sense to you, like, because in your discussion section, you're going to have to justify this, and it does not count to just say, like, I just picked something. Okay, so come up with something that makes sense in your mind that the two groups would differ. Because remember, our whole goal is to show that they're significantly different. That's what you're trying to do. Okay, so those are some options. But again, I also told you you could use some of these average variables you created. Like, you see these here? Mine are kind of mixed up. Yours probably are, oh, okay, that's not gonna work. But yours are probably not all mixed up like mine. But, so you'd be like, exercise, okay, my low exercise and my high exercise people, would they differ on how agreeable they are, right? Or their level of neuroticism or something like that. Okay, but you have to come up with something that makes sense. Once again, I'm just putting this in as a reminder. I know I already said it. Any of these variables in here, BF this, SC this, LS, whatever, off limits. Don't use them. Do not use them. I know they're tempting. I know you're going to look at them and be like, oh, but I really like that question. I'm sorry. No. Okay, and the reason is because these individual items are not supposed to be used on their own. Okay, they're part of scales. That's why you created these things at the bottom: extroversion mean, agreeableness mean, etc. So they cannot be used on their own here. You have to use the big composites that you made in Lab 3. Okay, so your task right at this moment, you need a hypothesis. Which variable are you going to pick that has two groups? Is it going to be the gender one, the age two groups, the GPA two groups, or the exercise two groups? Which one? Okay, got to come up with that. And you have to have your continuous variable. Okay, are you going to use anything from friendly 1 to purse rating 6? You can see the little items over here. Or are you going to use some of these composites down here? You're going to use extroversion or agreeableness. Okay. But you got to decide, because we're going to go over here to our fun example paper. And this is you should have your version of your paper open right now. Okay. So that you can just go in here, look, a hypothesis section. It says you should have one hypothesis for your t-test and one hypothesis for your correlation / regression, but we're not going to do regression. So, so this is the hypothesis for your t-test. So I'm going to say, I hypothesize that. Okay, I'm going to write mine that goes along with the older adults, the older people and life satisfaction and stuff, but you need to write yours here. Okay, so I'm going to say, I hypothesize that older participants will have higher life satisfaction than younger participants. Okay, that's my hypothesis. My hypothesis. Okay. Just note that when you say I hypothesize, it is spelled S-I-Z-E here. So keep that in mind. All right, so you might want to pause me right now until you have your hypothesis sorted, because you really can't move forward until you do that. Okay, so pause. Okay, so maybe you're back. Maybe. Okay. All right, so hopefully you have a hypothesis here that says something like, I hypothesize that men will be doing this more than the women, or that people who exercise less will, I don't know, have higher such and such than people. I'm not telling you what your hypothesis is, but you should have it written. Okay. All right, so then let's go back to our t-test handout, which is our friend here. Okay, so we've chosen our variables and we put our hypothesis into words. Okay, like here. So beautiful. We can move on to the second page where it's like, let's run the actual t-test. So I'm gonna go to my data, and I gotta go to analyze. All right, so we're gonna go to analyze, compare means, independent samples t-test. And I'm gonna make this a lot bigger so you guys can see it. I'm also gonna do display variable names over here, because you know I can't stand it the other way. Okay, so a couple things. Your test variable up here is your continuous outcome variable. Your grouping variable has to be your variable that has only two groups. Okay, makes sense because it's a grouping variable, it has two groups. If your hypothesis involves gender, you will use that gender variable right there. But if you're somebody who chose age, like I did, or the exercise variable, or GPA, you cannot use the ones that are right here, because these are not the ones that have just two groups. Okay, these are the original versions. Like age goes from 18 to 52. That would not work well for me. Okay, so I'm going to scroll down to the bottom, and that's where I should find the variables that have two groups, because I just created those earlier. So I'm going to go ahead and move like my age to groups variable into the grouping variable box. Now you see how it pops up with these little question marks? And the reason for that is that it doesn't really Oh, sorry, it's late. It doesn't know what numbers I've given these. Like, for all it knows, I've labeled them 7 and 8. Okay, I didn't, but maybe I could have, I guess. So I have to click on define groups. And group 1, I actually only gave the value of a 1, 2, and group 2 has a value of a 2. Okay, so we're just going to do continue. Yay. Good. Okay. And then, okay, so we're looking at age, and for me, my outcome variable is life satisfaction. So that's right here, but I'm just going to show you, if you picked like friendly 1 to purse rating 6, any of those are up here. These are all great variables. Personally, like purse rating 1 through purse rating 6, I love those a lot. They just have really nice hypotheses you could write with them. Friendly 1 to immoral 1, those are great, but you just have to remember when you're talking about them that they are not, like, this is not people rating themselves on friendliness, for example. They're rating themselves on how friendly they want others to see them as. Okay, and you got to constantly remember that when you're talking about it in your paper. So just don't lose sight of that. Okay, so my grouping variable is age, 2 groups, and my outcome variable is life satisfaction. So I'm going to move that over here. Okay, so I've done that part. If I go back to my t-test handout, saying like move your independent variable to the grouping variable box, define groups, move your dependent variable over, then you're going to click paste, then you're going to highlight it and run it. No big thing. Okay, I gotta stop yawning, y'all. I'm so sorry. Okay, so that is not what I want. What is this? Oh, sorry, my bad. That was a different thing. Okay, so I'm going to paste this. Yay, I pasted it and it probably went here. Okay. So now I'm going to highlight it and push play. Okay. So once you get your output, there is a lot to unpack here. A lot that is important. Let's start in the first box. Okay. So it has age variable broken down into 2 groups for the t-test, groups 1 and 2. Now, you might have to go back and look at your syntax to know what your 1 and 2 are. Like for me, the 1 group, those are my young people, and the 2 group, those are old people. Okay, if you used exercise, your 1 people, those are people who exercise less, and then your 2s are people who exercise more. If you're doing GPA, your 1s are low GPA and your 2s are high GPA. Gender should be labeled as men and women. So, okay. So it's looking at the 2 groups on life satisfaction. They didn't come out. I told you I did my best to make these people come out evenly, but because we have so many 21-year-olds, it was just not, like a 21 had to go somewhere, and all those 21-year-olds just went with old. Okay, it just had to happen. So yeah. Oh no, it's like the 20-year-olds. That's what the problem is. Oh, so many 20-year-olds out there. Okay, so we had a ton of 20-year-olds, and I couldn't make them old because then it really would have been lopsided. So anyway, they got to be 1s. I have my means here and I have my standard deviations. For your paper, you will need the means. You will need the standard deviations for each group. So if you're looking at this, look at my means here. Which group has a higher mean? It looks like my 1 group has a higher mean. And my 1 group, those are my young people. So their mean is 4.41, and my old people have 4.16. And you'll see like that's not a huge difference, but it could be significant with this many people. So we'll have to check. But unfortunately, that's like counter to what I hypothesized. Because I was saying older people would be more satisfied than younger people, but that is not what's happening here. Okay, so I'll need the means and standard deviations for my paper. Okay, so going down here, this is where we actually do the full test to see if our 2 groups are significantly different. And I'm going to really walk through this. If you're following along in your handout too, like there's this whole section on interpreting the t-test. And the part that I'm about to start is in this section where it's like the independent samples t-test box gives you 2 very valuable pieces of information. So all this information's here in the handout in case you're getting a little confused. Okay, so the first section, I'm going to call it the Levine's test for equality of variances section. It only has 2 little columns, the F column and the SIG column. Those are the only 2 things there. And basically what's happening here is it is just testing to make sure that the variances for your 2 groups are relatively the same. Okay? It is testing to make sure that the variances for your 2 groups are relatively the same. What I mean by that is that, you know how when we were doing t-tests, when we were doing ANOVAs, we talked a lot about homogeneity of variance. We were assuming that our 2 groups, or however many groups we were talking about, came from populations that had about the same variances, okay? And if you're thinking about the bell curve, I can't do a bell curve with my arms, but if you're thinking about the bell curve, like if my young people, if their variability is about like this in the bell curve, okay, but my old people are like this, okay, that variability is a lot less than this one, okay? This one would have a lot more variability than this group. That is problematic for your t-test, okay? So before it even will run your t-test, it's like, okay, let's just check the variances. Let's make sure that we're not dealing with a situation where one's like this and one's like this. If that is happening, then the SPSS program will make a correction for it, and that's fine, but you need to know if it's happening, okay? So we're gonna look at this because mine's a little bit on the edge. So I'm going to look at this SIG column. And basically, if my SIG column here, my 0.066, if that value is less than 0.05, then my variances are different, and that is actually a problem for me. Okay, so if my SIG value right here under Levine's test is less than 0.05, okay, smaller than 0.05, then I have a problem with my equality of variances, okay? It basically means I'm violating the homogeneity of variance assumption, okay? Now, for me, I'm fortunate here because it's not quite significant in that way. Like, it's 0.066, so I'm kind of like, all right. So they're not different enough for me to have a problem, okay? It's communicating that they're different, but maybe not different enough to have a problem. So because of that, I'm going to just move forward with assuming that I have equal variances. You see here where it says equal variances assumed? Yeah. What that means is that when you're looking at your t-test information here, look at this beautiful t, okay? When you're looking at all this t stuff, you can use the top line, equal variances assumed. So basically what I'm saying is if your SIG column here under Levine's test is higher than 0.05, so for me, mine's 0.066, which is a little higher, which is good, then you can use this top line, equal variances assumed. So it means you don't have a variance problem, move on, do your t-test, whatever. If your SIG value was 0.05 or smaller, so let's say you're looking at a SIG value that's like 0.021, then you do not have equal variances. You are violating that homogeneity of variance assumption, and that's okay. The t-test will take care of it, but you're going to have to use the numbers that go along with equal variances not assumed down here. Okay, so you need to determine right now where you are. What's right for you. So if you need to pause this, back up, listen to this again, just to check again, that's fine. But figure out, are you equal variances assumed or are you equal variances not assumed? Most of the time people are equal variances assumed. I usually have like, I don't know, maybe 5 in a class that have equal variances not assumed, but that's still 10 out of 44 people. So it could be you. So check it and see. Okay, once you figure that out, you can move on to the t-test information, which is going to be over here. I'm going to scroll. So this t-test for equality of means. Yay! The only information that you're going to need for your paper here will be your t-value, your degrees of freedom, and your sig two-tailed value here. Okay? Now, and again, remember, I have people still be like, which T do I use? Do I use the top one or the bottom one? Well, it depends. What did you just decide about these things? Are you using equal variances assumed, or are you using equal variances not assumed? So use the one that matches up with what you're supposed to be doing with your variance situation. Okay, so I get to use the top one because my Levine's test thing was okay, even if it's barely okay. So I'm going to use the top one. So my t value is going to be 1.876, which I will round to 1.88 in my paper. My degrees of freedom is 371, which here should just be n minus 1, right? So that means I have 372 people in this analysis. Yes, we do have more than that in this whole data set, but this just means some people probably weren't answering the questions for life satisfaction or age. That's okay. Okay. And then my p-value is 0.061. Now, for rejecting the null for my t-test, I'm setting my cutoff at 0.05, which means that my p-value has to be less than 0.05 for me to say that my two groups are significantly different. Okay, so this value right here under sig two-tail column, this is where it all everything hangs on this, okay? If your p-value is less than 0.05, then you can say that they are significantly different. Look at me. No, I'm not. I'm close. And remember, let's just talk about what this value means again. So for me, this is 0.061. Essentially, it is saying that there is a 6.1% chance that the difference that I see in these means here is due to chance. Okay, so there is a 6.1% chance that the difference that I see in these means right here is due to chance. And unfortunately, that is just too high. I'm not going to risk it, basically. So we're saying that 6.1% chance that this finding's a chance finding, so I can't say they're significantly different, okay? So if your p-value is 0.05 or smaller, then you can say you have a significant difference, and you would be what's called, what we say in class when we say like party. Okay, so if you're 0.05 or smaller, you can party. Unfortunately, I am not in that group. I'm crying, okay, crying in the closet because I'm sad. So yeah, sad day. Let's see. Okay, so let's just go look at how we're going to deal with this for our paper. I'm going to go back to this independent samples t-test handout really quick. Again, if you're watching this video and you're like, what is she saying? I don't quite understand. Everything is written down. If that's just an easier way for you to learn, then that's here, right here. So you can find that there. Okay, but you have done your t-test, so it's time to write this sucker up. Let's do it. Let's put this in our paper and be done with it. So I'm gonna try to like make this go here. I'm gonna be flipping between a couple things. Okay, last page of this t-test handout is like, it's time to write it up, and it gives you some models. So the first thing is like, if your two means are significantly different. So that means if over here in your sig two-tail column, your p-value was less than 0.05, then you get to use this top section as your guide. Yay for you, because you're partying. If you're like me and your two means are not significantly different because your sig two-tail column was above 0.05, sad, then you're going to use this as your guide, the bottom part. Okay. And really, just read through this with me so you can sort of see what I'm talking about. I'm just going to read the if your two meanings are significantly different part. It says, in your paper, you will say something like, an independent samples t-test was used to assess whether group one, and that's whatever your group one is. So that could be like young people, okay, were, for me, it was less satisfied with their lives compared to older people. The test was, well, for me, it was not significant. But if yours was significant, you could say significant, showing that my young people, and then you give their mean and standard deviation, were less satisfied than my old people, and you give their mean and standard deviation. Then you would leave the symbol of a T, leave it right there, because that you have to have that there because your reader needs to know that you did a t-test. But you would put in the DF value. So for me, that's 371 in here, equals whatever the t value was. For me was 1.88. That would go here. And then my p value would be 0.061. Okay. Now, some people get confused by this first way of writing it up because they're like, I don't know. Sometimes people will turn in papers to me that are like, an independent sample t-test was used to assess whether group one, and they'll like literally leave it in like more/less dB. I'm like, no, what? Because you're supposed to put in your variables. Like, this is just a guide. So then, because that was happening to me, I made another little example here that actually puts in real words for real things. So it's like, an independent samples t-test was used to assess whether older participants were more satisfied with their lives than younger participants. The test was significant, showing that older participants, mean standard deviation, were more satisfied with their lives than younger participants, mean standard deviation, and then with the T statement. Okay. So make sure that yours is reading more like this second little paragraph here. Okay, so I'm actually going to write mine up in the paper, and I hope that you're going to be doing this along with me so that you can check that off your list for Lab 4. So I'm pulling up my paper here. I'm going down to the results section, and we're going to be in the independent samples t-test. Our writing here will not be in bold, so I took the bold off. Okay. So I have like a nice little guide of wording that you can definitely use. All right, so I'm going to use the second sort of section here because my means were not significantly different. So I'm going to say an independent samples t-test was used to assess whether older participants were more satisfied with their lives than younger participants. Now, you should be writing something that's, reflective of whatever your hypothesis was, okay? So your independent sample set was used to assess whether, I don't know, men rated themselves higher in musical ability than women. I don't know what it is, but whatever it is, that's what you're putting there. Then my second sentence is going to be like me talking about how it's not significant. So the test was not significant, showing that older participants, okay. So this is where I need to go get the mean for my older participants. So for me, remember group 2, those are my older people. So their mean is 4.16, because I'm getting to round that up. So I'm going to say mean equals 4.16. And then I also need the standard deviation for them, which is 1.32. Okay, showing that older participants were not more satisfied with their lives than younger participants. I need, I need their mean as well. So the group 1, 4.41. All right, 1.17. Okay, And then I did a comma, and then I'll do my T statement. So T, and in parentheses will be my degrees of freedom. So I'm going down here. My degrees of freedom is 371 equals whatever the T value is, which is 1.88. And then my P value is equal to 0.061. Okay, a couple things here. First, all the symbols in your paper have to be italicized. So I gotta make my M italicized, this SD has to be in italics, other M has to be in italics, SD has to be in italics, T in italics, P in italics. Okay. What else? What else? What else? I feel like there was something else I was going to tell you. Oh, I know what it was. Okay. So, some of you out there, some of you very, very fortunate people will look at your independent samples t-test stuff. You will look at the SIG two-tail column, and you'll look at it and it'll say 0.000. And you'll be like, wow, that is below 0.05. I'm amazing, AKA very unlikely that my findings are due to chance. Reject the null, party hardcore. Got it. In your paper though, you cannot write it as P equals 0.000. For you guys, you'll have to say like, oh, sorry. P is less than 0.001. Okay, so if you're one of those very fortunate people who have a 0.000 sig two-tailed value, you need to write that as less than 0.001. Everybody else will keep it as it is with whatever the actual value says. Okay, so that's all you have to write up here for your t-test section. Not too bad, huh? Okay, hopefully not. I don't know. We're getting a little long in this video, and I still have to do a table and a figure, so we're going to make that happen. Let's go down. Let's go down. Okay, we will do some other stuff later. You guys, it hasn't been part of a lab necessarily, but you should be able to just have your references section done by now. It was in, I talked about it a lot, I think in lab 2. But all those references are already in that statistics survey. So your big thing is you need to go and double check that they're in true APA format. Yeah, so, but should be close to done. Okay, we're going to do the table and figure, and then those will be done, and they'll be amazing. So, for your table, the effect of your IV on your DV. So this is whatever your IV and your DV was. So my IV was age. So yours either was gender, age, GPA, or exercise. And on whatever your outcome variable was. So mine was life satisfaction. Yours could have been physical appearance, or desire to be seen as friendly, or extroversion. I don't know. Okay. So the effect of age on life satisfaction. Okay, down here where it has IV, I'm going to write age again. And then IV level 1, that's like, what is your first group? And I'm going to put young. Second group is old. And then I have to do the means and standard deviation. So if you're GPA, you do GPA, low GPA, high GPA. If you're exercise, you have exercise, less exercise, more exercise. If you're gender, you have gender, men and women. I think those are all the options. Okay. So I need to go back again and do my means and standard deviations. Sorry. You can either get those from your output, or you can go up and get them from your paper because you already put them in there. My output's right here, so I'm just gonna move that over. Okay. So my mean for my young people, oh no, back up. Okay, 4.41. The standard deviation is 1.17. Mean for my old people is 4.1. Is it right? Yeah, 4.16. And my standard deviation is 1.32. Okay, I'm leaving this little note here. It says standard deviations appear in parentheses beside means, because that's just clarifying for your reader what these numbers are. That's good. Table's done. Life satisfaction and age with my figure. First thing I want to point out here, you guys, is that this is not going to work if you are using some version of Word online. Okay, and I really hate to tell you that, I'm sorry, but you're gonna have to download like a true version of this document to get this to work. If you run into problems with that, then what you can do is, like, let's say you have your paper pulled up and everything's in there, and for some reason it's not doing it because you downloaded it from Word Online and it's like basically just one big picture that you can't edit, and that's problematic. Then what you could do is just download the example paper again and edit it in the example paper and then copy and paste it into your paper. So that's an option. But we're going to do it same sort of way here. So the effect of age on life satisfaction. So yours is whatever your variables are. Okay. If I go down here to my little IV, I can change that to age. DV can change to life satisfaction. Okay. These I'll have to change while I'm editing the data. So in order to actually edit these bars to be different, you have to right click on here and you're going to do edit data in Excel. Okay, so I'm going to have for IV1 level 1, that's going to be young. IV1 level 2 will be old. My young mean was 4.41. I do not, what was my other one? 4.16. Where did it go? Okay, 4.16. So my second one's 4.16. Once I do that, like as long as I've like clicked out of that second box that I was in, I can actually just exit out of this Excel thing and it should have changed my numbers over here. And it did. My bars look different. A couple things. Let me just move this over. Just troubleshooting for you guys who might be having issues. So first thing is that some of you might be in a situation where your two bars are both, or maybe one of them, I don't know, is right up here at the 8. And if you have any means that are above an 8, then you need to make this change with me right now, okay? Mine are not. My means were like 4 point something for both of them. But if your means are above an 8, you need to make this change. So we're going to go over here, click on the y-axis, and we're going to do format axis. And when you do that, it should pull up the axis options and it should have a minimum and a maximum here. And the maximum is currently set at 8, but if your means are above an 8, then you can change it to 10 because there are a couple of variables that we had that were on 10-point scales. So if you do that, it'll just change it to be on a 0 to 10 scale. And that'll help you to actually see that your means are different. Okay. All right. Oh my goodness, that's been a lot. I am actually going to go ahead and show you how to get your output into your appendix so you don't have to do it later. Okay. So let's just go back to the output. Here we are, our fun output. We've got group statistics box and independent sample t-test box. Both of these have to make it into your paper. You cannot just copy and paste them over because look at this independent sample t-test box. It's very long and it will not copy and paste nice. It's super problematic. I wish it would. It would make my life easier. But because of that, we're going to have to do what's called exporting the file into a Word document. So you're in your output. You're going to go to File and then Export. I mean, not your Word document. I'm sorry. You're in your output file. You're going to go to File and Export. When you do that, it's saying, hey, it's going to do a document for you. We actually want a Word RTF document. Yours might already be on that. Sometimes, especially when I'm in the labs on campus, it's already on Word/RTF. So we're going to do all of it. And I got to figure out where I want to put it. This is important because you're on a UNCP computer and you're going to need to be able to access it again in like a minute. So put it somewhere where you can find it. Honestly, putting things on the desktop is never, in my opinion, a bad idea as long as you're emailing things to yourself or whatnot. So I'm going to save mine to the desktop. I'm going to call it T-Test Appendix. Save. And I'm going to click OK. Okay, so when it does that, it should just save it to my desktop, which, you know, you could close everything and go to your desktop and find it. I'm going to do it this way. There it is, T-Test Appendix. All right, look at this beautiful thing. This is also not beautiful, not pretty, but it gives me what I need, so that's helpful. What it ends up doing is it basically breaks things down into different groups, which can be kind of weird. Hold on, let me move it over. And my Mac is not being super helpful. But you see here the independent samples t-test box was really long, and now it just breaks it down into two kind of rows, which is fine. Okay, so all you really have to have in your paper is the group statistics and the independent samples t-test stuff. So I'm going to copy all of that, and I'm going to come over to my example paper, and I'm just going to, oh no, don't do that. Look at me. I'm like, I'm just going to fix it and it'll all be fine. And nope, did not work. All right, friend, how can we make you work? Paste special, maybe? Do I want it unformatted? I don't know. Macs are weird, you guys. Oh no, I do not. Nope. Let's try. I'm hoping yours just worked out nice and you're not having to do this right now. Nope, nope. Don't like that one. What about PDF version? Ooh, that's nice. Okay. For me, I don't know what you're dealing with over there, because if you're on the UNCP computers, I think it actually works perfectly fine when you just paste it from one Word document to another. But if you're like me and you're having issues, the PDF version worked pretty well. Okay. All right, so let's just recap our situation here. You today should have a new hypothesis under your hypotheses section, the hypothesis that goes along with your t-test. If you come down here to your results section, you should now have 2 sentences in your independent samples t-test section with your numbers. You should also have your table completed and your figure completed. And you should have this information in your appendix. Okay, so hopefully you're good to go. I know this was a really long lab. It usually takes us 2 days in class, and then sometimes people have extra time outside of class to finish it up. So it is long, but hopefully everything was really clear. If you have questions, you can definitely email me and let me know, and I'll be happy to answer those. Okay, you guys, have a great time with Lab 4.